Welcome back everyone to the Hello World Guide. This is another episode of the Raycasting series, and in this video we are going to implement directional sprites. So before we begin, I'm going to go ahead and quickly run my show you the sprites.png which I modified, and now you can see that we have added some new sprites in here. So we had these three earlier, and now we have got this Pinky from Doom here, and you can see that this is not a single sprite, but instead this is like a collection of 8 sprites. So 1 2 3 4 5 6 7 8. So all of these sprites are basically they are directional sprites. So this each of these represents the Pinky viewed from a angle that is increasing by 45 degrees. So this is from front, this is 45 degrees, then this is again 45 degrees until we reach the back, and then we just loop over again. So these 8 angles, or these 8 directional sprites, we'll use these to kind of actually make sure that our Pinky can be viewed in 3D. So now we are going to go ahead and first of all I'm going to open up thing.h, and now you can see thing consists of a new boolean here called directional. Now if this boolean is true, then this means that the texture is a directional texture, which means that apart from this texture that we are storing in this variable, there are 7 textures after this texture that are actually the other direction. So if this bool is true, then this texture actually represents the start of 8 textures. And similarly, we have got inside of thing.def, we have got this as well. I'm gonna go ahead and open up thing.cpp. You can see we have got a new one here which I just called monster. The size is 0.75. The texture is 3, which is where the Pinky texture starts, but the directional is set to true. And the reason that is set to true is because this is a directional sprite, and that means that texture 3 till the next 8 textures, they are gonna be used for this monster. So now if I go ahead and open up game.cpp, you can see that when we are actually spawning this, so when we are, you can see here, when we are creating the shared pointer for our thing, we just, specify that definition directional here as well to create that correctly. So now I'm going to close everything down. Let's go under render.cpp to kind of see how this actually works. So in render.cpp, implementing directional sprites is actually fairly simple. So what we do is we first of all, let me go here. You can see we have got our sprite position here. Now this represents our sprite position with respect to our player's position. This is what we use for getting the view coordinates and everything. This also actually, if we normalize this vector, then it also represents the direction of the sprite from the player, and that direction is going to help us in determining the angle between the player and the sprite's direction and where the sprite is actually facing, and that angle is going to help us to display the sprite correctly. So you can see that we set the texture to things texture, and then if this is directional, then we change the texture. So what we do is we first of all get a vector to dir which is just set to the sprite position, but then we calculate its length and we basically divide it by its length to normalize it, and then we get a thing angle. We just take the thing's angle and convert it into we convert it into radians. That's because we are going to use radians for the standard functions. And what we do is we use this angle to calculate our sprite direction like this. Actually this is not needed, let me remove that. So with this thing angle that we have got, we calculate another float angle which represents the angle between the thing and the direction vector. So what we do is we use std8 and 2 which returns radians, so that's why we converted this to a radian first, and we get the 8 and 2 which gives us the angle of this direction.y and direction.x. We pass it those, and that gives us the direction of this, and then the angle of this direction, and then we subtract that from the thing's angle. And actually a much easier way to do that would be to convert this directly to degrees like that, and we can just remove this here, and we can use thing angle here directly like that. So after this, what we do is we round the angle to 45 degree intervals. So to round basically a float to a specified value, you can just divide it by that value, round it, and then multiply it by 45. And the way this will work is that our angle will basically can only be at 45 degree intervals, because we have got 8 sprites. So we round it to get that to the correct value, and then we use f mode to make sure that it wraps around and is within the correct 0 to 360 range. And if it's less than 0, then we just add 360 to make it within the correct range. range. And in the end, what we do is we just take our angle, divide that by 360, and then multiply that by 8. And what that gives actually, that is actually gonna be our integer coordinate. So we basically get that as our integer texture index. So let's imagine that the angle between the player and that was, for example, 40. We first round it, which gives us 45, and then we go ahead and make it is already within range. So this code does really nothing, doesn't change it. And then what we do is we take 45, divide that by 360, multiply that by 8 to get us the correct index of the texture we need to use, and then we add this to our texture variable, and later on we use this local texture variable here for the actual calculations. And now you can see that if I go ahead and run make, and by the way, I just went into the things editing mode and I added this pinky sprite here, which is at type index 4. As you can see, I added this here, and now you can see that I can go here and you can see I can see the pinky here, and if I move around, you can see that the direction of the pinky changes. From the back I can look at it from all 8 directions, and it's looking pretty good. It looks like a nice pseudo 3D effect. So yeah, that's pretty much it for this video. I'll see you in the next one, in which we'll implement some more advanced stuff, like some other things for improving our engine so that we can actually convert this into a working game. So stay tuned for that. Make sure to like and subscribe as well, and share this video with other people, and I'll see you in the next one, and bye.